problems based on heat capacities. Okay. Number 1, question number 1. There are two parts. A part is calculate the heat that must be supplied to raise the temperature of 2 kg of water from 25 degrees Celsius to its boiling point at atmospheric pressure. The average specific heat of water in the range of 25 to 100 degrees Celsius is 4.184 joule per Kelvin per gram. And the B part of the question is, how long will a 2 kW, that is 2 kilowatt heater, take to supply this energy? Okay, so these are the two parts of question number 1. Now let us discuss the solution. Well, we have already discussed earlier that the heat required for heating Q is equal to M multiplied by Cs into delta T. So we have to see what is the mass. Now M is 2 kg. 2 kg means 2000 gram. Okay. Delta T is 100 minus 25 degree, that is 75 degree. Now the specific heat Cs is 4.184 joule per Kelvin per gram. So this Q is equal to 2000 multiplied by 4.184 into 75, and this is 6.28 into 10 to the power 2 kilojoule. Okay, so this is the amount of heat required. This is the answer of part A. Now part B. The heat supplied by 2 kilowatt heater. Okay, heat supplied by 2 kilowatt heater is equal to 2000 joule per second. Okay, so the time required to supply 6.28 into 10 to the power 2 kilojoule of heat will be 6.28 into 10 to the power 2 into 10 to the power 3 joule divided by 2000 joule per second is equal to 314 seconds. Now if you convert this second into minute, then it is going to be 5 minutes 13.8 seconds. Okay, 5 minutes 13.8 seconds. So this is the answer. Now question number 2, numerical 2. Question number 2 is, a swimming pool contains 10 to the power 5, 1 into 10 to the power 5 liter of water. How much energy in joules is required to raise the temperature of water from 20 degrees Celsius to 25 degrees Celsius? The specific heat of water is 4.184 joule per degree Celsius per gram. Okay, now let us discuss the solution. Now Q is equal to M into Cs into delta T. Okay, now M is how much? 1 into 10 to the power 5. Okay, liter is equal to 1 into 10 to the power 5 into 10 to the power 3 gram. Why? Because the density of water is 1 gram per centimeter cube. So it is 1 into 10 to the power 8 gram. Okay, this is the mass of water. Then Cs is equal to 4.184 joule per degree Celsius per gram. Delta T is equal to 25 minus 20 degree, that is 5 degrees Celsius. 5 degree. So Q is equal to, heat supply is equal to 1 into 10 to the power 8 multiplied by 4.184 into 5. This is equal to 2.092 into 10 to the power 9 joule This is equal to 2.092 into 10 to the power 6 kilojoule. Okay, so 2.092 into 10 to the power 6 kilojoule of heat is required to raise the temperature from 20 to 25 degrees. Okay, now question number 3. Question number 3 is, again there are two parts of the question. Calculate the energy needed to raise the temperature of 10 gram of iron from 25 degrees Celsius to 250 degrees Celsius. Its heat capacity of iron is 0.45 joule per degree Celsius per gram. And the B part is, what mass of copper, a specific heat 0.385 joule per degree Celsius per gram, can be heated through the same temperature difference when supplied with the same amount of energy, okay, as above. Now let us discuss the solution. Mass of iron is equal to 10 gram. Rise in temperature delta T is equal to 250 minus 25 degree, that is 225 degrees Celsius. A specific heat capacity of iron is equal to 0.45 joule per degree Celsius per gram. So Q is equal to, energy needed is equal to M into Cs into delta T. Okay, so this is going to be what? 10.0 gram into 0.45 into 225 degrees Celsius. Okay, and this is going to be 1012.5 joule, and in kilojoule it is going to be 1.012 kilojoule. Okay, this is the answer. Now the B part of the question is, in case of copper, a specific heat for copper Cs is 0.385 joule per degree Celsius per gram. Delta T again 225 degrees Celsius. Now energy is Q is equal to 1012.5. Okay, so we have to calculate the mass. Okay, so energy, that is, we already know that Q is equal to mCs into delta T. So M is equal to Q upon Cs into delta T. Okay, and this is equal to 1012.5 divided by 0.385 into 225, and this is equal to 11.6 gram. So 11.6 gram is the amount of aluminium. So 11.6 gram is the mass of copper. Okay,